This product here is the Stirling Energy desktop engine that was developed for the ME2024 design class this semester. This is Team 1's generation, which includes Nicholas Bedard, Trevor LeMaster, and Andrew Kayota. So the brief overview of this Stirling engine right here, it's marketed as a DIY kit for the average consumer who wants to learn a little bit about internal combustion engines or anything similar to that. So what we're really trying to show here is processes including the thermodynamic cycle and just overall features of a standard internal combustion engine. In this case, it is an external combustion engine. So the first thing that we have right here, this is our heat source. It is just a little alcohol lamp. Right now we're actually going to run this motor in demo mode, so this won't be required, so we'll set this off to the side. So when you're coming up to this engine, there's a few things you'll notice. You have this LCD panel right here. This provides instructions and feedback for how the motor is actually running and operating to the user. So the first thing that you do is you turn the key switch, and you'll see the LCD screen pop on. The first instruction that you get is to light the candle underneath. And for that, we have this little infrared sensor right here, which senses whether or not the flame is actually present. So first thing that happens is you light your engine, and it goes into the starting sequence. It starts the motor, and then as it continues to spin, it displays the RPM on the digital display right there and the state that it's running. And once it comes to a complete stop, it then provides the message to the user that you then need to restart your program and then run the system again. So briefly to talk about what the actual device has just done, the starter motor right here connected its signal once the flame was detected after a prolonged period of time, and then once the flywheels were up to a certain RPM, this servo motor right here retracted the starter motor, allowing the flywheels to spin in a totally free manner. And finally, the last feature we'd like to point out is the integrated fan into the flywheel, which also doubles as an RPM counter for the tachometer. This integrated design allows us to reduce the number of components that are necessary in the design, and overall just simplifies the entire process. Thank you for listening, and we enjoyed doing this project.